very interesting joint opening between heavy duty and on-road, but also tackling issues on heavy duty, on the light duty diesel market. And now we'll carry on with heavy duty. Just a reminder, sorry, Ben has something.
Hey, just want to make a reminder, in case you're looking for the non-road presentations, and by those I mean looking at hybrid, electrification and autonomous in the off-highway non-road sector. That's in a different room right now, and I can take you to that if you're interested in that. I think it'll be an interesting discussion as well, and some of the alternatives. So if you're interested in the alternatives, basically where you want to go is out of this room, take a right, and there's a lift and an elevator, and it's a room sort of towards the back of the conference. It's seminar room 3. So yeah, thanks a lot. I'll pass over to
Thanks, Ben. Great. So as I said, if you are interested in non-road, just follow Ben. If you are interested in heavy duty, stay and let's kick off our discussions for the day. Our first speaker, we're going to be talking more about emissions today, mainly because yesterday most of the day was on CO2 fuel economy. So today we'll focus more on pollutants, NOx, PM, and on the Euro 6 standards. And we'll start with a presentation from Lennart Lindholm from Volvo Groups. Lennart has been introduced already in the joint opening session, but for those who are not here, he's a legislative diagnostics technology specialist for Volvo Trucks, and he has been the project manager for a large portion of the OBD development work associated with the main OBD steps taken in Europe, US, and Japan. And Lennart's going to be presenting on OBD monitoring for Euro 6. So Lennart, thanks for coming, and feel free to go ahead with your presentation.
Okay, then I will see if I manage the technology. Oops, sorry. Yep. This is what I will try to present. I will talk a little bit where we are on OBD and a little bit of the midterm challenge and what I see as a trend of what OBD is developing to future years. I will start with why we are having OBD, why regulators are having OBD diagnostic requirement in the first place, and a little bit what Euro 6, what it's all about, and then I get into the OBD part. OBD is part of periodic inspection, and then I will have some CARB California OBD challenges, and I will talk about remote diagnostics and expansion beyond emission, and those two last goes hand in hand. And I'm for the entire Volvo truck company, all the brands. And just a reminder for those that are not so familiar with this ODB or OBD or whatever it is called. It is referred to a system on board a vehicle or an engine which has the capacity of 3 things. First is to detect the malfunction affecting emission performance of the engine systems. It's purely about emission impacting failures. And then it should alert their occurrence by means of an alert system. That is typically the icon you see on the corner on the dashboard. So the operator knows that he actually needs to go to see the workshop. And to have a successful repair, then we also need to identify a likely area of malfunctioning by means of information stored in computer memory and communicate that information on board, off board. This definition was a little bit fussy, but this is actually from the R49, the international version of Euro 5 and Euro 6. And communication, that means that you do it in a standardized format through the OBD connector. And when it comes to likely area, that it should be a specific DTC identified exactly the root cause. So you know which one component to maintenance or in most cases simply replace. And why do we have a requirement for OBD? And it's really about identify gross emitters. If you have these 14 well-functioning vehicles that works as design and works the way they leave the factory, It only takes one individual gross emitter that can emit more than those, in this example, 14 vehicles. If you have a conversion efficiency of plus 95% on an SCR, and all of a sudden you don't have any conversion at all, of course, one individual vehicle will be worse than a whole package of vehicles. And a lot of malfunction that affects emission, especially on the after-treatment systems. You don't observe anything as a user, so it needs to be an onboard detection. If you have a hole in a particulate filter, if you do notice something as a driver, you typically notice that you got a slightly lower back pressure, which is good since it's on the high side from the beginning. So it will probably be better performance. So therefore you really need to have this on board. And this one is not just targeting for, it's targeting for the end of life of the vehicle. That is, the older the vehicle gets, the more important the OBD system gets, since it's more likely to be malfunctioning the older than it gets. And in conjunction to the OBD, we have another that goes under the name NOx control in Europe, or has SCR guidance in Europe. It's really about an SCR inducement system, and that is to avoid user misconduct, mainly with the SCR systems. And there will be some reports of that misconduct. There should be a systems that should do some punishment, torque limitation and speed limitation, and the speed limitation is in the range of 5 miles per hour or 20 kilometers per hour, depending on the regulation. And this is what happens in ice hockey if you act unsporty. If you act unsporty, and that is really unsporty, not to try to bypass the CR functionality. And then you get quite a big penalty in ice hockey. I will just put OBD in a context. This is the 7 pillars of the Euro 7, and the reference being Euro 5. You know them most by heart, so I'll go and read through. We decreased the NOx emission by a factor of 4, and we did that for public health, of course. And we also reduced the PM number, and more important, we have a new part number requirement, and we did that for public health, of course. And then we increased the use, the emission-related use for life. We increased that to more realistically 700. And then we also have this massive in-service conformity, which is in reality a new element. And there is about PEMS testing and biofuel blend emission compliance. And this is really that you look in the performance through a magnifier. You see things that you didn't see prior to the in-service conformity, the PEMS. And then we have an element of sending repair and maintenance information, a lot about the diagnostics information, to independent workshop and independent aftermarket tool manufacturers. We should send the same information to the independent as we send to our own network. That was a totally new element in Euro 6. And then we reinforce the OBD system. We had one in Euro 4 and Euro 5, but now it's much more comprehensive and can even be compared with the California regulation, to some extent at least. And then we enforce the SCR inducement. We put the ultimate step of 20 kilometers. And what's about diagnostics, that is really about number 6 and 7, and other presenters had covered the first 5, or at least the first 4. And this is what an OBD system is hardware-wise. No, I don't have it, but if you look from the top, you see an engine control unit. It's a lot about software. And the software portion of the onboard diagnostics, that is bigger than the software portion controlling the chemistry factory. Beside the emission-related control strategies, regeneration, heat management, it's getting to the portion of being half of the engine ECU in terms of portion for the onboard diagnostics. And then you see an instrument cluster with the icon. And then you see a cable. That is where we send out standardized fault codes, identifying the root cause, and all sort of additional information that is useful for the driver. And then you see a lot of sensors also. To set a diagnosis, we really need to sense something. You cannot just guess. You need a sensor value evaluated by algorithms in the ECUs. So it's really a distributed system. So the majority of the components, instrument cluster, engine ECU, NOx sensor, exhaust temperature sensor, pressure sensor, those that you have for other purposes as well. So almost 100%, not entirely 100% in all examples, but plus 95% we use existing sensor that you would have anyway. There are some cases where we have to add sensors. And the failure mode, since they are emission related, then they are primarily targeting for engine and after treatment. And we are in about 250 unique failure modes that we identified on all the components. So that is the magnitude of root cause that we are identifying on those systems. And OBD is one of the most detailed requirements that we have. It's very detailed regulated. It's about paragraphs. And the Californian, it's 120 pages, and there are about, on average, 7 paragraphs per page. And then that's just one of them. Then you have the European, the Japanese, the Chinese, and well, there's a lot of reading. Now I will take an example of what you can successfully use OBD for besides what was intended in the first place. This is, I take the example of utilizing the OBD information during periodic inspection. And this is a result from Oregon. And this is different year models, and as natural, when you test an older vehicle, it has a higher failure rate than compared to a new one. That is not the interesting part I will show. I will take what happened when they switched from emission testing by measuring physically, and instead starting to read out the result of the onboard diagnostics functionality that has been running for basically a year since you did the last periodic inspection. And if you see that it jumped up to more than twice, that means that if you would have continued not using just emission measurement, you would have catched 5% or less than 5% in 97, and now we catch about 12%. So we catch more than twice as many that would go undetected emission vehicles with emission-related failures that would have gone undetected. So it shows that the OBD that has been done on the road during redriving, it's more sharp than trying to measure the emission at idle and elevated idle. And in conjunction, so in Oregon, they replaced the traditional emission tailpipe with reading out the OBD information. And if you think about it, this is a rather small vehicle in my eyes. If you were to do a transient cycle on a heavy-duty truck, imagine what kind of chassis dyno you need. And as we are approaching zero in emissions, you get a challenge in measuring accuracy that is at least challenging for at least Volvo, which is one of the biggest truck manufacturers in our laboratory. We have measurement challenge. Imagine what you would have with less experienced people and what kind of equipment you would have. And besides that, the OBD system was more effective in the first place. And that is just plug in and read out the information with basically a computer bay, a laptop basically. So a long statement, but this is what they concluded, that the OBD is both more quicker and more effective identifying gross polluters than the tailpipe test. And it's also much clean, much easier to do. And it also provides information what needs to be fixed, not just go home and fix your car, it has high emission. Okay, what should I do? Here it gets the information exactly what is the root cause. Go change the EGR valve, that is your problem, for instance. Or the rear front lambda sensor, or whatever it is. You get the exact root cause. And it also so that there are emissions besides tailpipe, basically evaporative emission from gasoline cars. Those also create emissions, but you don't capture them by measuring the tailpipe. That one is covered by the OBD systems also. That is what they say with the fuel storage systems. That's sometimes that's an understatement. It never detects that one. So another example of a success story. Also, California is moving away from traditional emission testing towards relying on the result of the OBD systems. And here you see failures on, this is emission-related failures, not brakes and stuff like that, emission-related failures, where you have the fail by the OBD systems or fail by others, which is basically a tailpipe or an inspection, looking for tampering or stuff like that. You see two things. You see that there were some initial problems with the maturity of the hardware, and especially with the algorithms in the OBD system as such during the first year. But once it levels out, it is so that when you have an emission failure, then it's really about, it's the OBD system that detects that one and no other systems. And I will get into some of the challenges with the California OBD. I will just point out that we are in a process of upgrading the, oh, is this a clock that it ticks down? That process of updating regulation, which we have a binary review process, indicate that it should be every second year, but actually every third year we're updating it. There may be some requirement that was not feasible, and there were uncertain requirement, and there were missing requirement. And I will get into a little bit what is the core of it. And this process will be finalized by mid-2018. And there are some stakeholder meetings, where one of the stakeholders being myself and my colleagues in the industry. One thing that as a result of some observation on behavior on real driving, they want to have instantaneous NOx, and they want that one in a standardized format on the OBD connector, second by second. And they want the average drive cycle. I assume that they want that to compare with PEMS measurement. And there also was a long past filtration to get the history of the NOx behavior, and to get that information from the rear NOx sensor. And you store this in the bins. And they picture that they should store this in idle and vehicle speed intervals, and also in load segments. And it's current drive cycle and the long-term filtered. And each bin should be combined with numbers of engine spent hours in that bin. So you not just get the NOx in grams per British horsepower, you also get an indicator of how much of your total time you spend in individual bins. Now about remote diagnostics. And CARB has not decided how they want this information. They certainly want it through the plug-in alternative, or it could possibly be a Bluetooth, and that sends that one to an off-device services. Then it will be like standing on the roadside. And that roadside unit would then go to a central database for analysis. So the interface for the vehicle, it will be basically on the plug-in or the Bluetooth. But there are discussions whether we should go one step further, since there typically are some remote connections with a typical truck. And then we have an interesting alternative, unique requirement from China. They want information over there, and they want it in as a rolling buffer with 1 hertz, with 7 days capacity. The 8 days you can overwrite the first day. This is a 12 megabyte rolling buffer, and they want this kind of calculated engine net out power, max torque power, friction torque, and all these sensor signals. And you don't need to be Einstein to figure out that they intend to at least calculate gram NOx per kilowatt hours. You can do that by those. And you can do some other interesting calculations. And in more problematic, they want it through a TCP/IP, which is, okay, that is not so strange, but they want it according to GB blah 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 blah, which is a national standard of People's Republic of China. I'm not very familiar with that standard and typically work with the SIA standard or ISO standards. And then they have this thinking that it should be an onboard diagnostic device on board a vehicle that should do the over-the-air communication with an enterprise services. But what we in the industry do work with when it comes to remote diagnostics information, including those sensor signals and calculator that I show you that you need for the calculation. We have that one in a package of ISO standards that goes under the name of remote diagnostics. This is this package of standard, and it's especially the middle one, 78, which is the TCP/IP, the Wi-Fi standard. That is a web interface standard. That in any vehicles, independent of if it's a truck or a bus or a car, that one have a telematic gateway, which is modern vehicle typically have. And that communicate with an externals and a server that is per brand. And this is, in our case, the Volvo. In Mercedes' case, it's the Mercedes. In Fiat's case, it's the Fiat. And then this standard, this extended vehicle standard, it really defines the interface between our server and an independent third-party server, which could be Microsoft, IBM, or Bosch, or whatever. And we specify that interface, and that is really what needs to be specified. And then any third party can communicate to any vehicle through that standard. And in conjunction to that one, there is a standard being developed as a result of a legislated directive for Europe for the member states that they should have a minimum level of roadworthiness check beyond emissions on the safety-related issues. That's the electronic periodic detection inspection standard that is being developed as a result of a legislation that mandates that. And it makes sense to me. It makes sense to me. You cannot test an airbag or a stability control systems on during periodic inspection. How do you do that? Smash the car up to see if the airbag works. But you do have some diagnostics on those systems for obvious safety reasons. And OBD was from the beginning an fault identification, meaning that that little icon with an icon. And then we added this addressing the potential misuses of SCR with torque and speed limitation. And then we are going, we are either going remote, and then complexity more or less increases linearly. But if you go to safety-related issues, which we tend to do now, then really the OBD complexity, in my view, gets a little bit more exponential in complexity. And this is my final slide, and I think I have 7.5 minutes for questions and reflections.
Great. Thank you very much. Okay, so are there any questions for Lennart? Okay, there's one here. Microphone's coming. Just tell your name and your company, please.
Ralph Miller from MTU. Yesterday we have heard about plug-on SCR defeat devices that can be easily bought on internet. Is this a constant competition regarding OBD and those devices, or could you imagine that this problem could be dissolved?
I would say that the devices that we have seen so far, we saw them one yesterday. I didn't comment on that one. It was a plug-in. We have tested that one. That one doesn't work. You shouldn't believe everything that you have on internet. You can buy a little belt that vibrates, and you will lose 20 pounds in 3 weeks. You can buy that on internet. And all sorts of things that you can buy on internet. But we have observed that there are actually AdBlue. The keyword is AdBlue emulator. If you put that one on internet, you will get quite a few hits. And it seems like at least half of them seems to be working. And that is bad enough. And it was recently quantified about some months ago. It was by Heidelberg University. It was Dr. Dennis Pühler, and he managed to develop a method where he runs after a truck. He measures nitrogen oxides in the plume, diluted even though, but he measures nitrogen oxides and CO2, and then he divides NOx with CO2, and then you get the true tailpipe, since they are both gases and they dilute in the same percentage. And he managed to quantify that it hardly exists on the Western trucks, like German trucks. It was made in Germany, so it was primarily German. It hardly is non-existing. But it was a little bit more than 20% of the Eastern European that do had anti-NOx emission, clearly having an AdBlue emulator. And that was a bit of a shock for the industry. It was the first time that someone actually quantified it. And after all, European truck, they are not just around Heidelberg, they're everywhere. So I would assume that it looks the same in Dresden or Gothenburg. So now the industry we're really mapping how they actually work. We are sending out King at the border control, the Canadian, if you know that story. There apparently is a hole in our defense, and we are mapping where is that hole. We were a little bit shocked with how easy they enter the systems. And once we have, I think I've got a picture of how they do it. And I think I got a picture of what I can do to plug it. But if I plug that one, will I find another hole? After all, there are teenagers that hack into a Pentagon, and then just write a little note, Killer was here, just for the fun of it. So what needs to be happening in conjunction with that one, it should be at least illegal to have them. I talked to a Swedish colleague from the regulatory side, and he told me, Per Olund, he told me that Swedish police has stopped suspicious driver and identified they have AdBlue emulators. And the thing that the Swedish police do when you are caught with an AdBlue emulators, they do, you naughty boy. That is about what happens. They cannot even take it, and they cannot even charge them anything. If we have that situation, then nothing will happen. But I see a big, with this remote sensing there, I see a big opportunity. Then, of course, we can do a better job in trying to defeat devices. We are a little bit taken by surprise. It happens really fast. And it took a long time before anyone quantified that the problem actually was of that magnitude. Okay. Long answer, sorry.
Yeah. Any more questions? There's one in the front.
Please make it a question, not a speech.
Yes. No, the thing is, on the passenger car side, for example, insurances have evaluated last year systems where they can control where the cars are going by GPS. Where they can say, for example, you had an accident there, but there was a speed limit 60, you were driving 80. Is there a similar, are you planning something similar for trucks?
Not for Europe and the US, because it's illegal, especially in Germany, to have that kind of big brother watching you. But if you look in the Chinese China 6 regulation, they are mandating that you even have the GPS position accessible over the air for the government's server. But then again, it doesn't seem to be a big of an issue there. But
let's not kid ourselves. My mobile phone provider knows as long as I have my mobile switched on everywhere I am, yeah? So.
Yeah, but the interpretation about all the German OEM that GPS position on a truck or a car, that don't fly. That don't fly in terms of German regulation.
Okay. Any other questions? There are two at the back. We still have time, so let's go. Let's take these two questions.
Thank you. David Heaton, Caterpillar. Just a point of clarity, please. Your CARB and China remote sensing, can you tell me when that is coming into play, when it is coming to practice, and is it for every vehicle?
It's for the Chinese version of Euro 6 heavy duty, and it's for the second stage. It's going to be a China 6A that goes into play 1st of January 2020, and there is something called China 6B that goes into play 1st of January 2023, and this is a part of the 2023. The CARB is not, you mean the CARB, the NOx bins. That is the concept that they are pursuing, and I don't think once they have pursued a concept, then I can debate whether there should be bins of speed or bins of fuel burnt, but they don't give up the concept as such, and they haven't time set it.
Great, thanks.
But I would assume, I guesstimate is that it could be, what is it now, 17, it could be 21, 22, something like that. Not before 20, that I don't believe in.
Great. And another question at the back.
I have a question concerning the application of exhaust soot sensors for diagnostic purposes on DPF-equipped vehicles. So what is your view on the application of such sensors on heavy-duty trucks and on on passenger cars?
Was the question whether we will have soot sensor on trucks and buses? We already have it from, it depends on which manufacturer you talk about. It's on the roads of 14, 15 or 16. Some started 14 and 15, some waiting for 16 like Volvo. But on US versions, we do have a soot sensors. And it's really, the regulation doesn't mandate that you should have a soot sensor, but they tend to play with the wording in the monitoring requirements that you kind of have hard time arguing that you can do that kind of monitoring without the soot sensors. And in Europe, there is really no push for soot sensors. I don't foresee that anyone will start using a soot sensor until there is a Euro 7, if there is one.
Great. Another question here in the front.
I was interested to hear what you're saying about remote. So our construction equipment has been fitted with telematics for quite a few years. So every machine we sell in Europe, for example, has telematics. So all fault codes are remotely monitored. GPS position, fuel consumption, load speed, that's not something which the truck industry is using. Is that the case?
I would say that standard procedure today is to have it on, at least on a high-end commercial product, you have a telematic gateway for various purposes, and you do remote diagnostics, and you're probably in the range of, if you haven't even taken a step, to do remote software download, because you do have a need to upgrade the software to get rid of bugs that bothers the features for the trucks, or potentially issues with compliance. And it's much more convenient to do that over there compared to bringing it to a workshop, especially for your product, which you cannot necessarily bring to the workshop. You need to bring the workshop to the vehicle. So for commercial product, it should be very advantageous to do software or update over there.
Yeah, we don't do that at the moment. So it is only monitoring. Obviously, another step to be doing updates. Okay, thanks.
We have started with a little bit of software download over there, even though that we start with the simple ECUs. And the simple ECUs, that's typically not the one that you have frequent update of, but you need to start testing the concept in that way. Unfortunately, it's typically the biggest ECU that for a truck is typically the engine ECU, it's the main vehicle ECU, and it's the HMI. These are the big ones. That is why I have the most frequent updates. And the bigger it is, the more technical problematic it is to do it over there.
Excellent, thank you very much. Any final questions for Lennart? Okay, in this case, thank you very much.